We can represent sets using a Venn diagram. However, we need to draw the sets carefully, otherwise we'll be imposing additional restrictions on the relationships between the sets. For example, suppose I draw 3 sets as shown. Find the relationships between the sets. So note that there is some overlap between A and B, so A intersect B is not the empty set. Likewise, B intersect C is not the empty set. But there's no overlap between A and C, so A intersect C is the empty set. Now, just a quick note here. As we've drawn it, A intersect B might still be the empty set. There might actually be nothing in this intersection. So it's not guaranteed that it's not the empty set. However, by the way that they're drawn, A intersects C, there is guaranteed no overlap between the two, and so A intersects C is guaranteed to be the empty set. So we might also consider the set differences. Because A and C are disjoint, then A take away the elements that are in C is just going to be A itself, and likewise C take away the elements in A is just going to be C itself. Or let's consider another set of 3. So we note that A and C are completely disjoint, so their intersection is guaranteed to be the empty set. C is entirely inside of B, so it's a subset, and that also means that the intersection of B and C is C, and the union of B and C is B. Finally, we can find the set differences A minus C and C minus A. So, can we draw a generic Venn diagram for 3 sets? So we don't want any set to be contained by another since this forces the subset relation. And we don't want the sets to be completely disjoint since this means the intersection will be the empty set. So we need to draw 3 sets where any 2 can overlap and all 3 can overlap. And so we can draw them this way. We could draw a generic Venn diagram with 4 sets or even more. However, it would be very complicated, so we don't. So suppose that in a group of people we know something about their media habits. We can draw a generic Venn diagram. Note that the 49% who watch TV came from 4 distinct regions. So it will be kind of difficult to start with this number. Meanwhile, the 16% who watch TV and read newspapers come from only 2 distinct regions, which is still difficult to work with. However, the 5% who do all 3 come from just 1 region, and so we can place the 5% there. Now, those who watch TV and read newspapers fall into 2 regions, and we know how many are in 1. Since they're 16% altogether, then the remaining 11% must be in the other region. Likewise, those who watch TV and listen to the radio are from 2 regions, but we know one of them. Since they're 13% altogether, then 8% must be in the remaining region. Likewise, there must be 12% who read newspapers and listen to the radio but don't watch TV. Now, since there are 49% who watch TV and only 1 region remaining, then 25% of the people only watch TV. And likewise, 17% only listen to the radio, and 13% only read newspapers. And this accounts for 91% of the group. And so 9% do none of these things.